Imagine controlling a plague of insects, not with chemicals from a laboratory, but with powders ground from dried daisies or extracts squeezed from tobacco leaves. 2 millennia ago, Persian parents dusted their children's heads with powder from pyrethrum flowers to ward off lice. In the 17th century, farmers discovered that nicotine from tobacco could kill plum beetles. These were not folklore remedies. They were the first recorded botanical insecticides. For a while, they were all we had. Then, synthetic pesticides stormed onto the scene, and the old plant-based weapons were forgotten. But we are beginning to rediscover them. What if the secrets to pest-free gardens are hiding in forgotten plants and ancient practices? What if the next breakthrough insecticide is already growing in your backyard? Keep watching as we unearth the surprising, sometimes deadly world of botanical biocontrols. By the mid-20th century, synthetic pesticides promised miracles. They were potent, easy to apply, and seemed to solve insect problems overnight. For decades, their efficiency blinded us to the collateral damage: residues on our food, poisoned waterways, and pests evolving resistance. Ironically, early botanicals had fallen out of favor precisely because synthetic chemicals were cheaper and easier to produce. Only a handful of the world's 250,000 plant species had been properly evaluated for pest control, so the era of synthetics didn't just replace botanicals, it stalled research into them. The few plant-based products that remained, such as extracts from neem trees, existed quietly on the sidelines. Then public concern about environmental contamination and pesticide residues erupted. Scientists and gardeners began looking back at ancient remedies for inspiration. Our task in this film is not to glorify natural solutions, but to examine them honestly. Their promise, their flaws, and their forgotten stories. We'll meet plant compounds that paralyze insect nerves, seeds that repel nematodes, flowers that lure aphids away, and predators that do the hunting for us. If you think natural always means safe, prepare to be challenged. Pyrethrum, the quick knockout that doesn't always kill. Long before chemical factories existed, farmers ground the dried flower heads of the pyrethrum daisy, Chrysanthemum cinerarii folium, into a fine dust. This powder and the 6 insecticidal compounds it contains, the pyrethrins, are derived from the same flowers still grown in Kenya today. Pyrethrins work by disrupting the sodium and potassium ion exchange in insect nerves, causing rapid knockdown and paralysis. Within seconds, a cloud of flies collapses. Yet, this stunning speed has a hidden catch. Many insects metabolize pyrethrin so quickly that they recover and fly away. To compensate, modern formulations add a synthetic synergist called pyrethral butoxide, PBO. Pyrethrins are considered low in mammalian toxicity, but they are far from benign. Cats are highly susceptible, and overexposure can cause nausea, vomiting, and neurological disturbances in humans. A natural compound that needs a synthetic booster and poses risks to pets challenges our romantic view of plant-based. But if pyrethrum is so limited, why is it still widely used? Because, when used judiciously, it biodegrades quickly and is one of the few knockdown agents certified for organic gardens. Rotenone, a root extract that kills insects and fish. In the 1850s, another botanical insecticide entered the stage. Rotenone comes from the roots of tropical legumes such as Lonchocarpus and Daris. Native Amazonians long tossed these roots into streams to stupefy fish, making them float to the surface for easy harvest. When scientists learned that the same compound shut down cellular respiration in insects, rotenone became a popular garden spray. Yet its toxicity was far from trivial. Rotenone is extremely toxic to fish and moderately toxic to mammals. Pure rotenone is more acutely toxic than many modern synthetic insecticides. High doses can cause convulsions and respiratory failure in humans. Over time, regulators banned rotenone for most uses, and today it is hard to find. Its story serves as a stark reminder that natural is not a synonym for safe. What other plant-derived poisons have we forgotten? And why? Sabbatia and hellebore, sneeze powder, and vanishing stalks. Sabbatia is obtained from the seeds of Schoenocolon officinale, a tropical lily. When these seeds are aged and processed, they produce alkaloids like civadine and veratridine that attack insect nerves. Sabbatia powders cause insects to lose coordination, sometimes dying immediately, sometimes lingering in paralysis for days. As a dust, Sabbatia is among the least toxic botanicals to mammals, but its purified alkaloids rank among the most potent synthetic insecticides. The dust irritates skin and mucus membranes, inducing violent sneezing fits. A related plant, European white hellebore, contained similar alkaloids and was once used widely in Europe and America. Today, it is no longer available and is unregistered by the USEPA. The vanishing of hellebore from commerce illustrates how regulatory decisions can erase entire plant weapons from our collective memory. Rhyania, a slow stomach poison. Derived from the woody stems of Rhyania speciosa, this alkaloid causes insects to stop feeding soon after ingestion. Rhyania powders were once sold as dusts and sprays, but they lacked the dramatic knockdown of pyrethrums and the broad spectrum of rotenone. Its moderate toxicity to mammals and need for a synergist led to decline. Today, Rhyania is largely a footnote in entomology texts. If a botanical doesn't deliver instant results, will gardeners ever embrace it? Rhyania's story foreshadows the patience required for some biological controls to work. Nicotine, the deadly nerve toxin, from your cigarette. Most of us think of nicotine as an addictive stimulant, but its insecticidal properties were known centuries earlier. Nicotine, concentrated in tobacco leaves, is a fast-acting nerve poison. It binds to acetylcholine receptors, causing uncontrolled nerve firing in insects and mammals alike. Nicotine sulfate sprays were once common in greenhouses, and early farmers used homemade tobacco teas to kill pests. But nicotine is classified as a Class 1 poison. Pure nicotine can kill humans at minuscule doses, and its ability to penetrate skin and mucous membranes makes it exceptionally hazardous. Numerous accidental poisonings and deaths led regulators to ban or severely restrict nicotine insecticides. Ironically, modern agriculture embraced synthetic neonicotinoids inspired by nicotine's mode of action, but designed to be less acutely toxic to mammals. These compounds, however, have been implicated in bee declines worldwide. The journey from tobacco tea to neonics underscores the double-edged sword of mimicking nature. How many times will we repeat the cycle of adopting, banning, and reinventing plant-based toxins? Neem, a Swiss Army knife for pest management. While many first-generation botanicals faded, Neem, from Azadirachta indica, has resurged. Neem products include teas, dusts, seed extracts, and oil pressed from kernels. The primary active compound, azadirachtin, is bitter and functions as a feeding deterrent and growth regulator. Neem extracts can repel insects, disrupt chitin synthesis, suppress egg laying, sterilize adults, or act as toxins. Because these effects vary by insect species, Neem rarely wipes out a pest. Instead, it slows populations and allows predators to keep pace. Neem's complexity also means there is no single pathway for insects to develop resistance. Yet this complexity complicates quality control. Different preparations contain different mixes of active compounds. Neem oil, often sold as a horticultural oil, suffocates insects but lacks azadirachtin. When used properly, Neem is remarkably safe for mammals and beneficial insects. When overused, it can burn plant foliage and repel pollinators. Can gardeners accept a remedy that works slowly and subtly? citrus oils and essential oils, repellents and irritants. Citrus fruits aren't just refreshing. Their peels contain volatile compounds like D-limonene and linalool. Crude citrus oils consist of about 90% limonene, while linalool is found in small quantities in citrus and over 200 other plants. These terpenes stimulate insect nervous systems, causing twitching, convulsions, and paralysis. In laboratory tests, natural peel oil from Citrus aurantium repelled 2 spotted spider mites more effectively than synthetic blends. A synergistic mix of limonene, terpinolene, and citronellol outperformed any single compound. Citrus oils have also shown high repellency against mosquitoes and stored grain beetles. On the surface, these oils appear benign. Both limonene and linalool hold GRAS, generally regarded as safe, status, and are used as flavors and fragrances. Yet at high concentrations, they irritate skin, cause tremors in cats, and may even promote tumor formation in sensitized mice. Pennyroyal, hailed by some as a flea repellent, contains pulegone, a potent toxin that can cause liver failure in humans. Before burning that citronella candle, ask yourself, am I treating mosquitoes or exposing my pets to a neurotoxin? Secondary metabolites, growth regulators, and feeding deterrents. Plants are chemical factories. Beyond the sugars and proteins of primary metabolism, they synthesize an array of alkaloids, terpenoids, phenols, flavonoids, and other secondary metabolites. Many of these compounds evolved as defenses against herbivores. Some act as toxins, but many work by deterring feeding or disrupting development. Insects may taste a compound and simply stop eating, starving to death. Others may experience hormonal confusion. Molecules that mimic juvenile hormones can force insects to molt prematurely or prevent metamorphosis. An intriguing anecdote illustrates this concept. Entomologists in the United States and Hungary conducted parallel experiments, raising insect larvae on paper towels. In Hungary, the insects mysteriously developed an extra larval stage. Eventually, scientists discovered that the paper towels were made from Abies balsamea, a conifer whose natural hormones induced an extra molt. Plants like basil contain compounds such as juvocineem 2 that inspired synthetic insect growth regulators like pyriproxyfen. This story reminds us that we are constantly bathing in plant hormones that affect other organisms, sometimes in ways we don't expect. Ancient mixtures and forgotten remedies. The Aztecs and Mayans mixed corn and beans with chili peppers, rue and garlic to protect stored grain. Such mixtures likely worked as repellents or feeding deterrents. Capsaicin from chili peppers irritates mammals and insects, while allyl sulfides in garlic repel some pests. In parts of Central America, these practices continue. Quassia, derived from Quassia amara, produced bitter extracts used historically as insect deterrents. In Europe, farmers sprinkled sabadia powder on animals and floors. It didn't kill insects outright, but it scared them off. Such ethnobotanical knowledge is valuable yet often dismissed because scientific validation lagged behind. Could there be lost remedies waiting for rediscovery? Companion planting and trap crops, marigolds and nasturtiums. Not all botanical biocontrols involve extracts. Sometimes the plant itself is the solution. Marigolds, Tagates species, produce pyrethrum and thiophenies that repel a suite of pests, aphids, mosquitoes, whiteflies, squash bugs, cucumber beetles, and even root knot nematodes. Planting marigolds alongside tomatoes can reduce aphid and nematode damage while enhancing tomato vigor. On the other end of the spectrum are nasturtiums. Many growers swear by them as trap crops. Aphids, cabbage moths, and other pests adore nasturtiums and will congregate on them rather than on cabbages and roses. By planting a sacrificial patch of nasturtiums, away from your vegetables, you can lure pests out of the garden. Hoverflies and other beneficial insects are attracted to nasturtium flowers and devour the aphids they attract. When interplanted with cucumbers, tomatoes, eggplants, or squash, nasturtiums may repel cucumber beetles, whiteflies, and squash bugs. These living biocontrols require no extraction or formulation. They simply need space, sunlight, and poor soil. Is it possible that planting flowers is more effective than spraying poisons? Beneficial insects, predators, and parasitoids. Sometimes the best way to control a pest is to let something else eat it. Lady beetles, also called ladybugs, are among the most common garden predators. Both larvae and adults devour aphids, spider mites, and whiteflies. Lacewing larvae, often called aphid lions, are voracious predators that feed on the same pests. Praying mantids are charismatic ambush hunters, but their cannibalistic nature limits their impact on pest populations. Minute pirate bugs prey on thrips, spider mites, and other small insects. To keep these allies in your garden, you need to provide them with nectar and pollen throughout the season and avoid broad-spectrum sprays. Plant diverse flowers with staggered bloom times, and beneficial insects will stick around. Many species can be purchased and released, but without habitat, they will simply fly away. Biological control is not a quick fix. It is a partnership with complex ecological interactions. Our investigation reveals a paradox. Botanical insecticides were replaced by synthetics because they were labor-intensive, variable, and sometimes dangerous. Yet the very reasons they were abandoned, their complexity and diversity, are now their greatest strengths. Pyrethrum knocks insects down fast, but requires a synergist and caution around pets. Rotenone, nicotine, and sabbatia remind us that some plant poisons are too hazardous for home use. Rhyania's languid action teaches patience. Neem's multifaceted effects show that a single plant can act as deterrent, repellent, growth regulator, and sterilant. Citrus oils demonstrate how blends of terpenes can synergize to repel mites and mosquitoes, but also how even safe essential oils can cause harm at high doses. Companion plants like marigolds and trap crops, like nasturtiums, offer pest management without sprays. Lady beetles and lacewings show that predators can do the job for us. At this moment, we confront our own assumptions. The romantic notion that natural solutions are inherently safe falls apart under scrutiny. The cynical view that synthetic pesticides are the only effective tools is equally flawed. The truth lies in integration. The turning point is recognizing that our gardens are ecosystems. Every plant we choose, every chemical we spray, every insect we release creates ripples. The secret is not in finding a single magic bullet, but in weaving a tapestry of complementary strategies. So what does this mean for your garden? First, discard the idea that there is one correct natural spray. Many first-generation botanicals like rotenone and nicotine are gone for good, and for good reason. Neem-based products, when labeled and applied properly, can deter chewing insects and disrupt their life cycles. Citrus oil sprays may repel mites and mosquitoes, but should be used with caution around pets. Essential oils like cedar, lavender, eucalyptus, and citronella can repel pests, but should never be concentrated or applied directly to animals without veterinary guidance. Second, embrace plants as allies. Sow marigolds between tomatoes and peppers to deter nematodes and whiteflies. Plant a perimeter of nasturtiums to lure aphids and cucumber beetles away from your vegetables and provide a buffet for hoverflies. Grow basil, dill, alyssum, and fennel to feed the adult stages of predatory insects throughout the season. Third, cultivate beneficial predators. Release lady beetles and lacewings early in the season and provide them with pollen and nectar sources. Avoid broadcasting even natural insecticides across the entire garden. They can kill allies as well as enemies. Fourth, Remember that most botanical sprays break down quickly. You may need to reapply them after rain or heavy irrigation. Always follow label directions and wear protective gear. And finally, accept some level of pest presence. A perfectly sterile garden is both impossible and undesirable. A few aphids feed the ladybugs that will later save your roses. Integrated pest management is about balance, not eradication. Our journey through the hidden history of botanical biocontrols has taken us from Persian powders to modern integrated gardens. We've learned that plants have spent hundreds of millions of years fighting insects. They have armed themselves with toxins, growth regulators, feeding deterrents, and repellents that we can harness, but only if we respect their complexity. We've uncovered why certain botanicals were abandoned, their dangers to fish and mammals, their inconsistency, their labor demands. We've rediscovered the power of companion planting and trap crops, the quiet work of predators and parasitoids, and the cautionary tales of essential oils. Above all, we've seen that effective pest management requires humility. Nature does not hand us simple solutions. Instead, it offers a toolbox of strategies, each with advantages and drawbacks. When we listen to ancient practices and modern science together, we find approaches that are both effective and sustainable. The next time you reach for a spray bottle, ask yourself, is there a plant ally or a predator that can do this job for me? Could a row of marigolds, a patch of nasturtiums, or a handful of ladybugs be the answer? Perhaps the most potent pesticide for our gardens is our willingness to see plants not as passive victims, but as active allies in their own defense.